Welcome back, everybody. So I've got the exams graded. I'm going to hand them back at the end so that we're not distracted by them. Then you'll have a week to do them and turn them in. Once everyone's turned them in on Wednesday of next week, I'll post the solution guides to everything so that we can get prepared for the final exam. We got a little bit left to go over. So we got 4.1 to finish off, but we're not going to spend too much more time on it. And then 4.2 and then 4.3. And then we're all set and ready to go. So a couple things before I forget. You probably have been getting a bunch of annoying emails from Canvas about course evaluations. Is that correct?
Yeah.
So first thing I want to say is I'm sorry. They are annoying about it. It gets really, really obsessive on it. Like it keeps asking you to do it if you haven't done it. And it's going to keep doing that. So you're going to click on a link on Canvas and it'll say, hey, you need to do your evaluations. And then you'll say, no, I'll do it later. And you'll click on a new link and it'll say, hey, you need to do your evaluations. I have no control over that. I wish I did. I would turn it off immediately because you guys have enough going on. You don't need to be constantly pestered while you're trying to study. So I'm sorry about that. I wish I could change it. I talked to my IT admin. There's no way to turn it off. At least not that this current admin has we're hiring a new admin, IT admin. So maybe they might find a workaround, but either way, there's nothing I can do to stop that. So I'm sorry. Please don't take it out on me from that aspect. With regards to evaluations, a couple things in case you might have heard this speech before from one of your other instructors, but in case you haven't, and in case this is your first time doing an evaluation, they are completely anonymous. Whatever you write, I won't see who wrote it. It doesn't say Andre wrote this about my course. It just gives me a bullet point and then says whatever that person says. So there's no way for me to know who said what. Furthermore, there is no way for me to know until after grades have been entered. I don't get these things for spring semester, usually until about halfway through the summer. That's when all the data gets compiled and it gets sent out to all of us. So there's no worry about ramifications from an instructor. I mean, I hope by this time in our tenure together, I hope you know I'd never do that to any of you. But if you're worried about another instructor, I hope you don't have any bad instructors. That's ideally not what happens. But if you do, there's no worries about ramifications. They cannot do anything to you to harm you based on what you put in your evaluations. So you should put what you think of the course. Truly give your honest criticisms. And I'd especially like it for my course if you have the time. I look forward to reading these things, even if they're bad, even if students have bad things to say, because it's a way to improve my teaching, learning what you guys like and what you guys dislike. I take it into consideration every semester. And you might be thinking to yourself, if you do have a bad instructor, you might be thinking, well, they're not going to read it. And that might be true. It might be true that they won't read it, but their department chair will. Because every year we have an evaluation as a faculty member, and their department chair will look at their student evaluations, and that will play a role in their evaluation. So if enough of you guys speak up against a bad teacher, it will leave a mark. So please give your honest criticisms, knowing that you have nothing to lose there. It will not harm you in any way. It's only meant to help CSN become a better school. Because if you tell me things that you want me to do more of, that helps me make it better school for all the rest of the your classmates who take this after you guys. So I really appreciate your time and energy going into those things. As much as I love the comments like Phil, you rocked, or Phil, you sucked ass, right? Doesn't really help me. I love those comments, but what did I do that rocked? What did I do that sucked that said ass, right? What did I do that was the problem? That's the things I'm interested in. Did you like the use of color? Was I too hilarious? Was I too great of an instructor? Was I too humble? Those types of things. Those are the things I'm interested in. So, not actually the too humble thing. That's just a joke, of course. But if there's something that you really liked and you wanted to make sure that I make sure to do it in the future, I'd really like to know. That is if you have time. I understand that we all have our own lives, so if you don't get a chance to do it, that's fine. But please know that it does get looked at. Even if it's not looked at by your instructor, it will get looked at by their department chair when it comes time for evaluations. So any questions on that evaluation process? That's the way it works for everything at CSN. There's not any unique situations. We all get the same situation when we go into it, okay? So, all righty. Okay. So we'll go ahead and get back to where we were. We talked about it last time on last Wednesday about the two main systems of how, like two main methods of solving systems of equations. There's substitution, which is where you take one of the equations and rewrite it in terms of one of the variables and substitute it into the other equation. Or there is elimination or the addition method, where you make sure that one of the variables in both equations has the exact same number but opposite signs, so you can add them together and cancel it out. Either method is valid. It might ask you on your homework to use the elimination method or the addition method or the substitution method. I'm not your mom. I'm not going to stop you from doing it. If you like the elimination method more and that's the only one you want to do, that's fine. That being said, I will say that both have their merits, and there are certain circumstances in future math courses where substitution is far easier to work with than elimination. So both are good to have practice on because they both have niche cases where they're better. So I'll talk about which ones I think are better in different circumstances. With this one right here, part A, I think, honestly, there's not I don't think substitution would be the right call. Because no matter what I do, no matter which one I try to solve for, which variable I try to solve for in either equation, it's always going to end up being a fraction. And if I can avoid fractions, I will. So I would recommend using elimination on this one. So that's what I'm going to do. What variable should we get rid of? Oh, this is another thing. When it comes to elimination for this one, there's a better choice. Should we eliminate y or should we eliminate x? Nick.
Why? Because it's divisible by, or nine's divisible by 3.
No, that if I was using substitution, yes. But the reason why I say y for elimination or the addition method is that the numbers are already opposite signs. So I don't need to worry about multiplying by a negative number, which can sometimes cause a little bit of issues. So I'm going to eliminate y, but you can definitely do it on your own time and eliminate x and see if you get the same number. I promise you will. So I need to find a number that they both go into. And that would be 6 here. So I'm going to multiply the first equation by 2 and the second equation by 3. And if I do that, now I've got 8x minus 6y equals 18, and 21x plus 6y equals negative 18. Doing so allows them to have the same coefficient on the y terms, so I can add these two equations together. And I really, really recommend on this exam, like on these types of problems, if they show up on an exam, on the final exam, because they could. Not saying that they will, but they might. I really recommend having like a colored pencil with you, just so that you know that that whole 2 is not just being applied to the left-hand side, it's being applied to everything of the equation. We're doubling the entire equation, not just the left-hand side, not just the right-hand side. We can't just double one side of it. It makes it not the same equation. So otherwise, what you could do is you could, like, I've had plenty of students do this type of a situation where they do 2 like that. If that makes it easier for you to remember, do that instead. So now that they have the same coefficient on the y's, but different signs, I can add them together, and that will cause them to cancel when I add these two equations together, and I get 29x equals 0. So x is equal to 0. Cool. Nice, neat, easy one to work with. Then I can use either equation. I should use the original versions of them, not the multiplied versions, not the 8 minus 6y equals 18 or the 21x plus 6y equals negative 18, because those have my work on them. I am human. I make mistakes. Better to plug it into the original equation. So it doesn't matter which one you choose. I usually try to choose the one that has smaller numbers because smaller numbers are easier to work with. So I'm going to plug it into, and then I'm going to take 4x minus 3y equals 9 and take this information and plug it in. So I get 4 times 0 minus 3y equals 9, which gives me y equals negative 3. So the solution is the point x comma y, which is going to be 0 comma -3. Couple nuances here to talk about, unless there's any questions. This might be review for many of you, and if that's the case, kudos. That means this will be a nice, neat thing to work with if it shows up on the final. But a couple minor nuances about this situation. The answer is not x equals 0, y equals -3. It's a coordinate point. At the end of the day, a system of equations, in this case, a 2x2 system, is an equation of two lines in a coordinate plane. So the solution is where they both are equal to each other. And that will be a coordinate point. It will be an intersection point between the two graphs. So the answer is 0 comma -3. It's not x equals 0, y equals -3. There might be occasional situations on Alex where it just makes you enter the x and y separately, but that's a relic of the past that needs to get updated. The other thing is you don't need to write the x comma y equals. That's just my way, because what if I had solved for y first? If I had found y first, my lizard brain would say, okay, -3 comma 0, which wouldn't be the correct answer. So I always write that to remind myself, okay, x goes first, y goes second. Otherwise, I make the mistake. You might be better than I am. And if so, awesome. Kudos to you. This next one. I would say either elimination or substitution would be fine. No, elimination would be better. Elimination would be better, but substitution wouldn't be too terrible. The reason why elimination would be nice is because all you need to do is multiply if you want to get rid of x, all you need to do is multiply the first equation by 2, which is what I'm going to do. Multiply by 2. And if I do that, I get 6x plus 4y equals 12. And the second equation, I didn't do anything to it, so it's -6x minus 4y equals -12. And you might be able to write what the answer is going to be here right off the bat. And if so, cool. But otherwise, we're going to add them just like normal. And we'll see that everything cancels. We get 0 equals 0. On the left-hand side, the 6x and the -6x cancel, the 4y and the -4y cancel, and then on the right-hand side, the 12 and the -12 cancel out, and we get 0 equals 0. That's a true statement. And if it's a true statement, that means that there's infinitely many solutions. So in particular, that means that this is a consistent dependent system, because it depends on what x and y are to find a solution. So consistent, because it will have solutions. That's why it's consistent. Inconsistent systems don't have solutions, but it's a consistent and dependent system. I'm not going to test you on that, and I can guarantee you they're not going to require that terminology on the final exam. We usually just want to make sure you can solve them, figure out how to work with them. So as long as you get to the point where you get 0 equals 0 and you claim that it's infinitely many solutions and write what the solutions are, you get full credit. The solutions are therefore x comma y, where this y equals the line from above. So in particular, we'll take 3x plus 2y equals 6, and we'll solve for y. We get 2y is equal to -3x plus 6, which gives us that y is equal to -3 halves x plus 3. So the solution is x comma -3x, -3 halves x plus 3. It's all the points on the line y equals -3 halves x plus 3. So that'll have an x coordinate of x and a y coordinate of the line itself, -3 halves x plus 3. That's how we write the solution to a consistent dependent system. Honestly, though, if I would doubt it. it's always a nightmare to have that happen on an exam. So like if this were to show up, if it were, I don't think so. Inconsistent systems and consistent dependent systems don't typically show up, but if it was, I would give you full credit if you just wrote that there was infinitely many solutions. That's all that matters to me in this course. In math 253, so linear algebra, that's when knowing whether it's a consistent dependent or consistent independent system makes a lot more difference. So we're just going to work with mainly just solving real ones. All right. Any questions on that? So as long as you get a true statement, it means that it didn't matter what the variables were. You would always get to a true statement, meaning that there is infinitely many solutions. And then if you get to a false statement, that's an inconsistent system. There's no solution. All right, this next one. Substitution would be a very bad call because I have to solve for them and I have to do a bunch of division and I have division of fractions, and that's not very fun. So elimination would be better. And what I'm going to do, pro tip, get rid of the fractions first. Get rid of fractions by multiplying by LCDs first. So this first one, the LCD of the first equation, 2 and 5, that would be 10. So I'm going to multiply that equation by 10. Second equation, there's only a fraction of third, so I'm going to multiply it by 3. And if I do that, I get 5x minus 6y equals 8. And then 5x minus 6y equals 15. And you might see where this is going to go. I can immediately claim right now that it's going to be an inconsistent system. But let's go through the process. We need to choose one of the variables to get rid of. I'll decide to get rid of x. So I'll multiply by -1. That's all that's needed. And that gives me 5x minus 6y equals 8. And then -5x plus 6y equals -15, which I will therefore add together to cancel the x's, but that actually ends up canceling everything on the left-hand side, and we get 0 equals -7. This is a false statement. So it is an inconsistent, it's no solution. Because we get to the point where we get to a false statement, that means that there is no solution. There was no way to get this thing, because regardless of what x and y are, no matter how much you slice it, you'll always get down to a false statement. Any questions on that? Okay. The good news is, by the way, so we're going to move on to the application section, which will still give us more practice with solving these systems. And then also after that, when you solve 3x3 systems, it requires solving 2x2 systems. So we're still going to get plenty of practice at this. So applications. Once again, there is no way to solve word problems. There's no finite way that will always work for every word problem. You're always going to start with something and then go back to the drawing board over and over. My helpful tips is to say, what are you trying to find? It will help you define your variables. Because if you ask yourself that question and answer it to yourself, you will find out what your variables need to be. And then you want to convert the statements into mathematical equations. Please remember that is means equals in mathematics. And then make sure you define your variables. It helps me a lot when I'm grading, and it'll also help you a lot. So a family has 2 cars. The first car has a fuel efficiency of 30 miles per gallon of gas, and the second one has a fuel efficiency of 25 miles per gallon. Last week, the two vehicles went for a combined total of 1,700 miles. It's a lot. It's like, that's, how far away is some place that's 1,700 miles? It's like, I think from here to Anaheim is like 400. So they both went on trips to Anaheim to go to Disneyland with each one of their kids separately. So for a total gas consumption of 60 gallons, how many gallons were consumed by each car that week? Jesus, in a week? I should change this problem. That's ridiculous. But either way, we look at this problem, we say, what am I trying to find? The last sentence is usually the one that gives you that. It's how many gallons in each car? So let X equal the gallons of first car and Y equal the gallons of the second car. It does not need to be a coherent sentence. It could just be let X equal first car, Y equals second car. But I wanted to be very particular that it is gallons. But if you wrote on the exam X equal first car, Y equals second car, that would be passable. It helps us out. So now that we know what X and Y mean, we can start creating some equations. What's one of them? Yes.
60 gallons.
A total of 60 gallons. If I take the number of gallons of the first car plus the number of gallons of the second car, that should add up to a total of 60 gallons. So let's highlight that statement from pink. X plus Y equals 60. So how do I use this information? Last week, the two cars drove for a total combined amount of 1,700 miles. So the number of miles that car one got would be the number of gallons of gasoline that it used times the number of times its fuel efficiency, because that'll tell you, like, if you use 6 gallons in your you get 10 miles. Like, let's say you get 10 miles per gallon. Terrible car, maybe a 1968 Charger. Or one of those cars from the old days, and something else. If you get 10 miles to the gallon and you use 6 gallons, you travel 60 miles on average. So what we're going to do from the green, we have that 30x plus 25y is equal to 1,700. So we have a system of equations. I would recommend substitution here. I think substitution would be far easier because I don't need to do any multiplication. I don't need to do any division. I can just substitute X in terms of Y or Y in terms of X. It's your call. I'm going to make Y equal to Y equals 60 minus X. And then I'm going to take that and plug it in for Y. So that gives me 30x plus 25 times 60 minus x equals 1,700. And go ahead and solve that. Use your calculator when necessary, because I don't want to do 25 times 60 in my head. It's 1,500 in case you don't have a calculator on hand. Should get that. Which gives me 5x equals 200, which gives me that x is equal to 40, right? Yep, 40 miles. And then I'll also use this and the fact that y is equal to 60 minus x to say that y is going to be 60 minus 40, which is 20. So I can box in x equals 40, y equals 20. And I can just leave it like that because I've already defined my variables. I've said what x and y are equal to in the very beginning. I said that x is the gallons of gas, y is the gallons of the second car's gas. So if any teacher marks you down on this type of a problem, by the way, in the future math courses, you can let them know, like contact me. Well, ideally, you should tell them first, like, hey, I defined the variables. So it's clear from the context that x is gallons and y is gallons. So I shouldn't be marked down. If they still say no, let me know. I'll bust out a katana and we'll go to war for you. So, but point being, if I didn't define my variables, I would have to write a statement. I'd have to say the first car used 40 gallons and the second car used 20 gallons. If I didn't define my variables, which is fine, it's fine to do that. But remember, I'm an alien grading your exam. If I don't know what X and Y are, then I can't figure out what this means. All right. Then any questions on that? These ones are always a little weird, the cleaning solution or the percentage mixture problems. Currently, a cleaning company has two different cleaning solutions. One that is 2% bleach for normal wear and tear, and an industrial one that's 10% bleach. But they're planning on releasing a new product that's 5.5% bleach, labeled as an all-purpose cleaner, like Dawn Power Wash, right? You know that Dawn Power Wash is legitimately just Dawn dish soap, water, and rubbing alcohol. I can send it to you guys. There's a formula for it. I've got the recipe if you ever want it. So you don't have to keep buying those those things from like Costco or whatever. You can make your own power wash. It's literally just rubbing alcohol, Dawn dish soap, and water. So don't buy it. It's a waste of your money. Just buy the big tub of Dawn dish soap. But anyways, they're planning on releasing this new product that is 5.5% bleach. That's supposed to be an all-purpose cleaner. How much of each solution should be used to fill a 30 fluid ounce bottle? Okay. So ask yourselves, what are we trying to find? We're trying to find the original, we're trying to find how much of each solution, the 2% and the 10% solution that is needed. So let's let X equal the FLOZ of 2% and Y equal the FLOZ, the fluid ounces of the 10%. So one of these equations is very, very intuitive. When I'm making this new bottle of the 5.5% bleach, I'm taking the fluid ounces of the 2% and the fluid ounces of the 10% and pouring them into the same container, which has to have a maximum of 30 fluid ounces. So the 30 fluid ounces right here from purple, we get that X plus Y has to equal 30. That equation makes sense to me. That equation definitely makes sense. The next one is the hard thing, in my opinion. I'm going to tell you what the equation is. Second equation is 0.02x plus 0.10y is equal to 30 times 0.055. That's the second equation. And I want us to think about why. I'll explain in just a moment, but think about why that is. Like, you can probably see why it's connected, right? 0.02 because that's the 2% solution, 0.10 because that's the 10% solution. But then why is it the 30 times the 0.055? So in short, if I take the number of fluid ounces of X that I put into the bottle, there will be 98% of that will probably just be water or some other weird compound that they have, but 2% of that will be bleach. So from the 2% bleach, if I take 2% of the amount of fluid ounces that I get, that's the amount of bleach coming from the first solution. Then if I take the number of fluid ounces of Y and multiply it by its percentage, that's the amount of bleach that is coming from the second equation. And I want that to add up to a total amount of 5.5% bleach in 30 milliliters. That's why I'm taking 30 and multiplying it by 0.055, because I want to know the amount of bleach that's going to be in there. The first thing gives me the amount of bleach coming from the, so that you can write this down if you want. This is the amount of bleach coming from 2% solution. This is the amount of bleach from the 10% solution. And this is the amount of bleach in a 30-ounce bottle with 5.5% concentration. Sorry, I know that's hard to fit into there. If you want me to restate it because it's hard to read, I'm going to zoom in so you can see it better, even though my handwriting is pretty bad there. 0.02x, that's the amount of bleach coming from the 2% solution. 0.10y is the amount of bleach coming from the 10% solution. And then 30 times 0.055, that's the amount of bleach in a 30-ounce bottle with a 5.5% concentration. Yes, Connor.
So we're just focusing on pure bleach.
Yes, just like the second equation is pure bleach. That's a tricky thing. The good news is, by the way, you might see this in your homework, or it maybe shows up on the exam. I'm not sure. I haven't seen the final exam yet. But all of these problems, if you see percentages in them, they all get done the exact same. It's like the percentage of the first thing times X plus the second percentage times Y equals the total amount times its desired percentage. It's always the same. Even if it's not, maybe it's talking about percent nitrogen in fertilizer or whatever, it's always going to be the same thing. So once again, with this one, I would highly, highly recommend using substitution. Substitution would be far easier to work with here, in my opinion, because we have that X plus Y is equal to 30. So we'll do that. X plus Y equals 30 implies that Y is equal to 30 minus X. So we get 0.02x plus 0.10. I'm just going to write it as 0.1. Well, actually 0.10 to make it a little bit easier to look at. 30 minus x equals 0.055 times 30 is 1.65. In case you were wondering where that came from, you can write that, but you don't have to if you already know. All righty then. So then we get 0.02x plus 10% of 30 is 3 minus 0.10x equals 1.65. 1.65 minus 3 is negative 1.35. So we get negative 0.08x is equal to negative 1.35. I get that X is equal to 16.875 fluid ounces, and then Y would therefore be 30 minus 16.875, which is 13.125. So those are our answers. And since I've already defined my variables, I don't need to specify fluid ounces. I've already stated that. Any questions on that?
Do we use substitution?
I used substitution, yes. Elimination could work. If you want to use elimination, I would recommend multiplying the second equation by 100 first, to get rid of the decimals because they're all hundredths, right? 0.10 is, or I guess probably multiply by 1,000 to get it to be nice, neat numbers, but it doesn't really, it'll be fine. Or you could just multiply by 0.02. It might be fine to do that if you're okay working with your decimals. Cool. And all right. Looking at time, I think we're okay. Because we're supposed to go over 4.3 on, yeah, we should be good. An air traffic controller is tracking two planes. To start, plane A is at an altitude of 3,330 feet, and plane B is just taking off. Plane A is gaining altitude at 25.25 feet per second, and plane B is gaining altitude at 80.75 feet per second. Determine how long till the planes are at the same altitude, and B, the actual altitude when they are level to each other. Okay. So plane's altitude, plane A's altitude. So I haven't seen this one in a while, so I'm going to just kind of mess around with it to figure out what I want to do. How long until the planes are at the same altitude? Let X equal the seconds on plane A, and Y equal the seconds on plane B. So that's a weird statement, but what I mean to say is that the altitude of plane A will be given by the number of seconds it's been traveling. And so the seconds on plane A will give me the altitude at different situations. So the altitude of plane A is going to be Ooh, wait. Let's see here. Because this is like, I have an idea of what I want to do, but it might not make much sense. But let's see. So altitude of plane A is going to be equal to 3,330 feet plus 25.25 feet per second times the number of seconds. And the altitude of plane B is going to equal 0 plus 80.75 x, or times. Ooh. So it shouldn't be y because we're measuring it at the exact same time. So this is not right. We're going to cross this out. Let x equal the number of seconds transpired. See, even I make mistakes. I wasn't sure at first. The reason why, let me explain why I knew that I was not right. Because if I do that, if I do the, we're measuring them at the exact same time. We're trying to figure out when we just started, the air traffic controller is tracking the two planes, and we're talking about right then and there when they start tracking them. That time signature is the exact same. The only thing that's changing is the altitude of A and the altitude of B. So it should be 80.75x like that as well. So part A is asking, we want the altitude of A equaling the altitude of B. That is to say, we have 3,330 plus 25.25x equaling 80.75x. So this is kind of not even really a system of equations. I mean, it is, but it isn't. The way we solve it isn't typical, but it still is in the same classification as a system. There is a way to write it in a different way, but it's just not very pleasant. This would be the most intuitive way to do it, in my opinion. Solve this, subtract the 25.25 from both sides. 3,330 equals 80.75 minus 25.25 is 55.5x. So that gives us that x is equal to 3330 divided by the answer, 60 seconds. I don't even need to write the 60 seconds. So you can just write x equals 60. That's how I found part A. It's just finding the number of seconds. And it works out because we're talking about, we figure out what the altitude of the plane is for any given second measurement. 3,330 plus the rising altitude per second times the number of seconds. Plane A, plane B is starting on the ground, so it's 0 plus 80.75x. Set them equal to each other to find that with a place where they have the same altitude. That would be when they're equal. You get 60 seconds. And then it says part B is the actual altitude. So B, we're going to plug x equals 60 into either equation because they should be at the same altitude here. So it doesn't matter which one I use. I'm going to use plane B, which equals 0 plus 80.75 times 60, which will be 4,845 feet. I don't necessarily, like, since I know what like plane altitude of plane B, since I already know what that is, I've already defined that equation. It's assumed from the context that this is measured in feet, so I would be fine with you just writing 4,845. But if you wanted to be very, very careful, you could write the feet as well. That one, your teacher might have a little bit of ground to stand on for marking you down, but even still, I'd just go up to them and say, come on, give them a break. Okay. Now we get to go on to 4.3, unless there's any questions on this. All right, not 4.2, 4.3, 4.2. So we already talked about what it means to be a solution to a system. It's an ordered pair or an ordered triple or an ordered quadruple that solves all of the equations present. So in this case, it's an ordered triple that solves all three equations. So there's nothing new. We don't need to check about what it means to be a solution to one of them and then things like that. It's fine. But I want to talk about how you do it. Now, there are many procedures. If you learn how to solve these a different way, that's your call. You can do it as long as it's mathematically valid. I don't care. This is my method. I found that it makes the most sense and it's very, very systematic. But if you like it a different way, that's your call. So step 0, you're going to label each equation E1, E2, and E3. First equation, second equation, and third equation, or A, B, and C. It doesn't matter what you choose. And then what I like to do is I like to decide which variable you're going to want to remove and choose the equation to be your eliminator. The pro tip is to look for variables that have a coefficient of plus or minus 1, because then all you need to do is multiply by the coefficient on the other equations to get rid of it. So I've chosen like if you decide that you want to eliminate X, I don't think there's a good choice there because all of them have different numbers and there's not an easy number that goes into all of them. Maybe if this was a 6 here and this was a -9, then E1 would be a good choice because 3 goes into 6 and it goes into 9. But as it stands, None of them work together. So you could do E1 as your eliminator, but it wouldn't be a great choice because there's not much going on there. If you're eliminating Y, I would make E2 my eliminator. Because E2's coefficient on its Y term is just 1. Furthermore, and so that would be a good choice. If you're eliminating Z, I would choose E1. Now I can choose either to eliminate the reason why I would choose E1 if I'm eliminating Z is because the coefficient on the Z there is nice and neat. It's just 1, but you could do it otherwise. You don't have to do it this way. It's just this is me showing you the intuition that you start to get as you go further and further and solve more and more of these. You start to realize which one would be the best. Now, do you guys want to eliminate Y or Z? It doesn't matter to me. Z? Sure. I did Y in my notes, so let's go off script. That sounds great. Let's do Z. Let's eliminate Z. So, using your eliminator, you're going to use the elimination method to remove your chosen variable from the other two equations, which will leave you with a baby 2x2 system. That's a very, very technical term in mathematics. It's called a baby 2x2 system. It's a true story. That's how they call it. So, since we're using our eliminator, E1, it's always going to be involved in both of these situations. So we're going to work with E1 and E2. So we've got 3x minus 2y plus z is equal to 2, and E2 was 5x plus y minus 2z is equal to 1. I'm eliminating z, so I'm going to multiply the top equation by 2, which will get me to 6x minus 4y plus 2z is equal to 4. And I didn't do anything to the bottom equation, so it's still 5x plus y minus 2z equals 1. At which point I can add these things together, and the z's will cancel, and I get 11x minus 3y is equal to 5. The substitution method can work for these ones, but it is annoying as all get out. So I don't recommend it, but you can if you want to. If that's the way you want to do it, just channel your inner Bob Ross and you're good to go. That's the first equation of my baby 2x2 system. And then I'll use my eliminator on the third equation. So I'll do E1 and E3. Write them down. So E1 was once again 3x minus 2y plus z equals 2. And E3 was 4x minus 3y plus 3z is equal to 7. This time, to eliminate the z, I'll multiply my first equation by -3. So that brings me to -9x plus 6y minus 3z equals -6. And then 4x minus 3y plus 3z equals 7. I didn't change anything about the second equation, so it stays the same. And then I'm going to add the two equations together, which is something that I can do with equations. If they're both equal to each other, I can add two equations together. Like if there's two equations, I can add them together and the truth value of the solution doesn't change. So we'll add these together, which will cancel the 3z's. We get -5x plus 3y equals +1. Now we've just got a 2x2 system. And so we just need to solve the baby 2x2 system. So we've got 11x minus 3y equals 5. and negative 5x plus 3y equals 1. Oh, that's really nice. That's neat. We don't need to multiply by anything. We can just add them right from the get-go. That was super nice. So we'll do that. Add them together. 3y's cancel. We get 6x equals 6, which gives us that x is equal to 1. And I'm going to underline it based on, if you remember from last week, on Wednesday of last week, I told you why you should do this, is that these things can get very, very messy. So it's hard to parse through your work sometimes. So if you underline your answers, your variables that you solve for, it'll make it easy for you to find them later on. And either way, to solve for y, we can use either one of the equations in the baby system. I'm going to use the first equation, but we can use the second equation. Let's use the second equation. 5x plus 3y equals 1. Taking this information together, we get negative 5 times 1 plus 3y is equal to 1. That's negative 5 plus 3y, so it becomes 3y equals 6, which gives us y equals 2. Any questions so far? Yes, Connor.
Is it a coincidence that the Y's were just able to cancel like that?
Yeah, this was a fluke. When I solve for, well, actually, if I solve for y, if I eliminate y, it ends up working out the same. That they just happen to have that. That's not always the case. This was just a fluke example where that ends up being nice and neat. Because I picked these numbers kind of randomly out of thin air, and it just so happens that that happens. That's pretty cool. Doesn't always happen. And then, now that we found two of the variables, we can plug it into any of the three equations. I'd recommend your eliminator to solve for it, but that's not really required. You can use any of the three equations. Though you can use any of the three original EQs because it has to solve any of the three equations. It has to solve all three of them. It's not enough to just solve 1, 2, or 3. So we'll plug them into E1. So I've got x equals 1, y equals 2, and I'm going to use E1, which was 3x minus 2y plus z equals 2. Utilizing all this information, I've got 3 times 1 minus 2 times 2 plus z is equal to 2. That's going to be 3 minus 4, that's negative 1. So negative 1 plus z is equal to 2, which gives us that z is equal to 3. So the answer is an order triple x, y, z, which will equal 1, 2, 3. Boom. It's as easy as 1, 2, 3. Get it? That's the answer. I heard a snort of air, so that's enough for me. It's enough for me to go on for another couple days. Thank you. Then, of course, optional step 5 is to check your work, of course, right? You're sick and tired of me saying that, but you can check your work by plugging it into any of the other equations. Check your work by plugging answer into the other equations. You don't have to do it if you're confident with your algebra. Usually speaking on these problems, it can happen that you get fractional answers. It's not unheard of, but most of the time on Alex, they'll be integers. So if you're not getting integers, I would really question my work and I would check it. I would check in another equation to see if it works. If you're getting nice integer numbers, you probably did it right. My go-to is if I check, it should automatically work in the first equation that I chose. So plug it into another equation. If it works, you're probably good. If it works in 2 of the 3 equations, it's probably solid. Any questions on that? No? Good. Okay. So, as a reminder, a solution to a 3x3 system is an order triple. That is this. That is a solution to all three of them, right? So this means the solutions are 3D points. They're points in 3 space. And furthermore, this is something that will get talked about in Calc 3 in Math 283. But equations of the form, linear equations of the form ax plus by plus cx equals d, they represent planes in 3D. So like a sheet of paper. So, where was I? 3D points. As a fun little side note, just in case you haven't been told this, do you guys know that we all see in 2D? We only see in 2 dimensions. We don't see in 3D. Because if you were able to see in 3D, I'd be able to see what all of you guys ate for lunch today. That's what so a 4-dimensional being could see in 3D. We can only see in 2 dimensions because I don't even know if you guys have legs right now because they're hidden behind the desks. But that's just a fun little tidbit. But anyways, a linear equation in 3 variables represents a plane. 2 equations represents a line. 4 variables would be a hyperplane, and so on and so forth. That's what we call a plane. It's just a sheet of paper that extends indefinitely. And so the cool thing about linear algebra, which is what we're doing here, we're doing the start of linear algebra, is that with a linear system like this, like what we've been doing, there is always only one of 3 options. There is either an inconsistent system, i.e. there's no solution. There is a consistent independent solution where there's exactly one answer, or there's a consistent dependent where there's infinitely many. So it took me a long time to graph all of this. And I made this in Notability, and I want you guys to ooh and ah about it. It took me a long time to draw these, but I did them myself. It was a lot of fun, but it was also annoying as all get out. So there are 3 different ways you could get an inconsistent system. You could have 3 stacks of paper stacked on top of each other, but not actually on top of themselves. In which case there's no place where they all intersect. Or it could be like the second one where there's 2 sheets of paper that are vertical and 1 piece that's kind of skewed. So yes, they do intersect, but they don't all intersect each other. Or you could have it like this where they all intersect, but not at the same spots. And so the answer to this one is like there's no solution, no solution, and no solution. This would be an example of a consistent independent. There's exactly one solution right in the center where they all intersect. You could have a consistent dependent, so they could all intersect at the same line. So like this line right here is the solution set. Or they could be all in the same plane. In which case you get like every point on that plane is the solution. So just a fun little tidbit. I thought it was cool. So I hope you think it's cool too. It was a lot of fun drawing that, trying to get it. Took me a good hour or two. And then I showed it to my wife, and she was like, "Good job, job." And then I got my tail to wag because I'm a little dog, right? Yeah, I did a good job. I'm a good boy. Anywho's, so let's go ahead and solve some more problems. This one, by the way, the one that's missing a variable, sometimes these ones, they end up causing more problems than you think. They end up, even though they look like they're easier, they seem to be harder because they don't fit the exact mold that we're looking for. So, but we'll get to do it just the same. What variable you guys want to eliminate? I think there's a clear choice. Y would be a good one. I would say Z because Z is already eliminated from one of the equations. But we can do Y if you'd like. Do you want to do that? Let's do Z. If we have time, maybe we'll do the other option too. So I'm going to choose to eliminate Z. So this is E1, E2, and E3. Which eliminator should I use if I'm eliminating Z? E2, because it has a coefficient of 1. If you wanted to eliminate Y, I'd use E2 as well, because the coefficient on the Y is 1 there. So I'm going to make E2 my eliminator. And so I have to eliminate Z from E1 and from E3. It's already done in E3, but we'll get to that in just a moment. So E1 and E2. So E1 is 3x plus 9y plus 6z is equal to 3. And E2 was 2x plus y minus z is equal to 2. So to eliminate z, I will multiply the bottom equation by 6, and I'll be all good. Be all gravy. That gives me 3x plus 9y plus 6z is equal to 3. And then 12x, excuse me, plus 6y minus 6z is equal to 12. Then I can add those two equations together, and the z's eliminate, leaving me with 15x plus 15y equals 15. Huh. Fascinating. You could divide this entire equation by 15 if you really wanted to make it easy to work with. Make it just x plus y equals 1, because you can multiply both sides of an equation or divide both sides of an equation by a non-zero number, and it stays balanced. It stays equivalent. But you don't have to. But that is nifty that it's 15x plus 15y equals 15. Then we'll do E2, our eliminator, with the third equation, E3. But it's already done. Z has already been eliminated from the third equation. So we just use x plus 5y equals 1. So our baby 2x2 system is 15x plus 15y equals 15. And x plus 5y equals -1. We could either eliminate x or y, or we could do substitution. It's totally chill. Yeah. Say again. I don't know. I don't know. I was making sure you guys are paying attention. Should be 1. Thank you for catching that. So I'm going to multiply. Oh, I know why, because I know we're going to have to multiply by a negative number here. I think I was just getting ahead of myself. We'll multiply. I'm going to eliminate y, but you could also eliminate, you can eliminate x if you wanted to. But I'm going to multiply by -3. And that will yield 5x plus 15y equals 15. And the second equation will now be -3x minus 15y equals -3. Add those together. 15y's cancel. 12x equals 12. Excuse me, x equals 1. Then we can use either equation from the baby system to solve for y. I would recommend the second equation. It's far better, far nicer to work with. So with x plus 5y equaling 1, we can take this information. We get 1 plus 5y is equal to 1. That gives me 5y is equal to 0. So that gives me y is equal to 0. Any questions so far? All right. Last but not least, we have to solve for z. We can use any of the first two equations because the third equation doesn't have any z's. So let's just use E1. So we have x equals 1, y equals 0, and we'll use E1. which is 3x plus 9y plus 6z is equal to 3. I probably should have used the second equation. It would have been easier, but it doesn't matter. This information tells me that 3 times 1, so 3, plus 9 times 0, or 0, plus 6z is equal to 3. And that gives me 3 plus 6z, so 6z is equal to 0, which gives me z is also equal to 0. That can happen. It could be that the answer is 0, 0, 0. It's weird, but it could happen. So the answer is x comma y comma z, so it's going to be 1, 0, 0. That's our solution. And we can check our work if we really want to, but we don't have to. As long as we're confident in our algebra. And then an additional one note is, once again, this is for our note-taking purposes. That's why I've done all this algebra. If you want to just do this in your head and say this is 3 plus 6z immediately, do that. Do that, absolutely. If you want to skip some algebra, you are more than welcome to do so. Any questions on that one? No? Yes, no, maybe so. Okay. So this one here, I deliberately did this one because you'll see these on there. I don't like when they do this. It makes me mad because it just doesn't look right. Because notice that each equation is missing one of the variables. So when I see this, I don't like it. It starts to get me the heebie-jeebies because the y's aren't in the right spots, the z's are in the right spots. So instead, rewrite it so that it's all nice and neat and lined up. So instead, I'm going to write it as 2x plus z equals -5. I'm going to leave space where the y would be if there was one. And then 3x plus y, leave the space where the z is because it doesn't have one, equals -10. And then 3y minus 4z equals -6. I don't know why they do this. Like I get it, but at the same time, like, why would you do that to me? It's so mean. All right. So now that we've got it looking better, E1, E2, and E3. What variable do you guys want to eliminate? Makes no difference to me. I would say that there are two, that there is a best option, a very, very close second best option, and then the third option. Is y the best? Yeah, it's second best in my opinion. I like the fact that the z and 4z, they're already opposite signs, so I don't need to multiply by negatives. So I would think that z would be the best option, but only by a very, very slim margin. Y would also be a good choice. X would be the worst choice because then I have to do more multiplications because 2 and 3 don't have anything in common. But let's do y. Might as well. We're going to eliminate y, which means we should probably use E2 as our eliminator. So if I do E1 and E2, it's always involving my eliminator because my eliminator is the thing that's eliminating the variables. But in E1, y is already eliminated. Y is already eliminated from E1. So we just have 2x plus z equals -5. Then we'll do E2 and E3. So E2 was 3x plus y, leave some space in the right, equals -10. And then 3y minus 4z equals -6. All right, I'd like you guys to finish the rest of this. You'll notice that when we add these things together, you're gonna get a magic x to appear now in the last equation. It's gonna have x's and z's, and the y's are gonna go away. So go ahead and work through that one. Slowly fill in details. Are we ahead of schedule now? Is that possible? Is it possible that I'm actually ahead of schedule? No. Okay, no, review catch-up day. So we are on schedule, but darn. Had my hopes up for a second. Dashed them just swiftly. You should get negative 9x minus 4z is equal to 24. And then you should be able to solve this system by yourself. At least. What do we do now? I got the answer up here. Well, not officially yet. I need to write it as a coordinate or an ordered triple, but I got the answer. So it's going to be x comma y comma z. X was -4, y was 2, and z was 3. So -4, comma 2, comma 3 is what you should get. Okay. In the interest of time, I don't want to rush the last one. Plus, I need to give you guys your exams back. So let's recap this one real quick. So, once I eliminate it from the second equation, I got negative 9x minus 4z equals 24. So I got 2x plus z equals -5, and negative 9x minus 4z is equal to 24. I think z is the clear choice for elimination, though you can use substitution. So I multiply it by 4. That allows me to cancel everything out. I get negative x equals 4, so x is equal to -4. And then I plug it into either one of the equations. I chose the first equation because it was smaller numbers. And then I got that z was equal to 3. And then the thing is, I actually didn't even need to use either of those equations. I could use, to solve for z, I could have just used equation 1. And then I could use that to solve for the other variable. It didn't really matter how I did it, but to solve for y, I can use either one of the equations that has y's. Luckily for us, they only had to plug in one of the variables. So if I use E1, did I use E1? Was that E1? I can't tell. No, I used E2. All I need to do is plug in x is -4, and then I can solve for y and get 2. So I get the point -4, 2, 3. And that's my solution. If you want to do this one on your own time, we're gonna start off with it on Monday. I'll extend the due date of the homework and the quiz for this week because we technically didn't finish it, even though it's pretty approachable. But this one, if you want the solution, if you're bored this weekend and want to do it, the answer is not pretty. It is 28 over 27, -86 over 27, and 31 over 27. It's not pretty, but sometimes life isn't pretty. So it's a good process to help you out with those things. So I'm going to pass back the exams. You have until next Wednesday to turn them in. Once they're all turned in, I'll post the solution guides to them. Overall, the performance was better on this one, so I'm super pleased about that. So I'm going to go ahead and stop the recording. If you guys have any questions over the weekend, feel free to email me. Otherwise, you have a great rest of your day, a great weekend, and I'll see you on Monday of next week. Make sure you avoid the doom scrolling, avoid the social medias if you can, and spend time with friends and family, and write your congressperson, yada, yada, yada.